for this week, I've decided to do number 33 from Chapter 10. And this problem is revolving around W.L. Brown, a direct marketer of women's clothing, and minimizing operations costs for the operator call center. So there are two costs that are associated with this problem. The first being the salary of hired operators, as well as the lost profit that can be accounted for due to calls being missed due to too few operators. So in this problem, we need to determine how many operators should be hired for a given hour in order to minimize the number of missed calls, but also to minimize that cost as well. So as part of the problem, we have some data for our inputs. We have our operator's salary per hour, which is $20, and our lost profit due to a missed call, which is $6. We know that one operator can handle approximately or exactly 15 calls per hour. Also important is our discrete distribution of the number of calls. We have the number of calls and their corresponding probabilities. This will be important in determining our hourly phone calls that come through. So as part of our simulation, our decision variable here is the operators that we need to employ in order to minimize the cost. So since we want to look at several different values, we are going to do a risk sim table. We're going to do 6 simulations with values ranging from 6 to 16 in order to determine where the lowest cost will fall. And then for our simulation, we have these inputs. Our hourly phone calls is going to be our random number, and this is going to be determined from our discrete distribution table. So we're going to do a risk discrete formula and input this distribution table here. And then we also need to account for the salary cost that is associated with the overall cost. And that's a simple equation where we are multiplying the number of operators we decide to employ by their hourly salary. And then finally we have the lost profit cost. So for this one I did an if clause saying if our hourly phone calls, B17, is greater than the number of operators times the amount of calls that they can take during a day, or during an hour rather, then we need to do this equation of subtracting number of operators times the number of calls they can receive, subtract that number from the hourly phone calls that come in. However, if the hourly phone calls is smaller than the calls that can be handled by the number of operators on hand, then that lost profit cost will be 0. And then our total cost, which will be our risk output, is simply the salary cost plus the lost profit cost. So once we have all that set up, we're going to do 6 simulations to account for the 6 different potential operators to employ, and then we're going to do 1,000 iterations. So I already ran the simulation, and down here we have some summary statistics for costs. We have our 6 simulations. I grabbed the mean, the standard deviation, 5th percentile, and 95th percentile cost. And we can see here that our highest cost is actually with just one, in simulation 1 with 6 operators, and it continues to decrease until we get to simulation 4 where we hire 12 operators. That's where we have our lowest mean cost, and this would be our lowest cost and our recommendation for W.L. Brown. We would recommend that 12 operators be hired in order to decrease total cost.